We will now start the new manufacturing proposal, the food processing equipment. This presentation video takes approximately 15 minutes. Let's begin. At first, let us explain about the food processing equipment market. The food processing equipments are widely used in food processing plants, school lunch centers, and catering companies. Various processing equipments are needed to slice, bake, and fry many ingredients like noodles, bread, meat, and vegetables. The global food market volume is forecasted to grow rapidly with the increasing world population and diversified consumer needs. The growth is expected particularly in Asia and ASEAN regions. To support the increasing food demands in the future, food processing equipment are expected to contribute significantly in production efficiency with a safe, reliable, and tasty food supply. The food processing equipments have been manufactured under strict international guidelines on hygiene and safety such as ISO and EHEG. Moreover, in recent years, the requirements on health and safety of equipment operators and the reduction of food contamination risks are becoming even more rigorous. For this reason, while complexity of manufacturing increases, higher quality with lower cost and shorter lead time have been strongly demanded. The manufacturers are under pressure to change to new manufacturing methods for better production efficiency without relying too much on skills. Let us now introduce some specific examples of new manufacturing: frying frame, forming equipment frame for flattening dumpling wrappers, and drainage sink for water and waste oil. First, let's use this fryer frame as an example to introduce new processing methods for reducing welding work. Traditionally, the square pipe used as a fryer legs is cut into 3 pieces with circular saws and welded together. When welding round pipes, welding places are scribe marked as illustrated in the paper drawing, and fixing of the right angle should be done by fixing support jigs. This method is time-consuming and requires experienced skills for precision finish, but it still is a very troublesome work. Today, we would like to introduce the new processing method to reduce welding with laser cutting. The features of laser processing is to cut even complex shapes freely with accuracy. Now, square pipes cut into shapes like this. By using this area as the leveraging point, the piece can be bent manually with precision. With this method applied for the leg parts, all 3 pieces can be combined into one, thus eliminating several welding areas. Also, joint areas for square and round pipes are shaped this way. By inserting these round pipes, we can achieve the product's final design. This will reduce the time-consuming positioning task for tack welding, and the welding work starts right away. It is also easy to maintain component accuracy without experience and skills. Laser cutting changes pipe processing completely. Next, let us propose the reduction of machining process by using the forming equipment frame of thick stainless steel. Strong force is required when flattening dough. Therefore, thick stainless steel parts are used for a structural frame. Thick stainless steel sheets are not only difficult to process, but the beauty of a cut surface is also required. Besides, fabrication methods are very limited and machining is commonly used. Today, we introduce Silky Cut as a new alternative to process thick stainless steel that achieves high-grade cutting edge with laser. The forming equipment frame is 20 mm of thick stainless steel. As you see here, the piece has smooth, aesthetic, and shining edge. The lead time is surely shortened by the deletion of machining and the reduction of finishing process. Let us explain about Amada's laser technology for the Silky Cut. The laser beam generated from oscillator will be adjusted automatically to the optimum beam diameter for Silky Cut by mirror polarization. The gas flow is also optimized by using a nozzle developed for this purpose to the assist gas outlet. Silky Cut, the high-grade cutting, is realized by combining these technologies. Finally, we will propose reduction of bending and welding processes by taking thin stainless steel drainage sink as an example. When you see products designed like this, how do you imagine the unfold shape? There are many factors you need to consider, such as dividing position for bend feasibility, keeping bend accuracy, welding process, and impact of heat distortion. It is very difficult and time-consuming task even for the very high-skilled workers. Now, let's look at the unfold shape together. The first unfold example is aiming the reduction of bending process. By dividing into 4 parts, the number of bends is reduced and bending accuracy is easily maintained. On the other hand, it is difficult to accurately weld the parts together, and many welding lines possibly cause large heat distortion through a lengthy area. Experiencing welding skill is required to maintain product's accuracy. Contrarily, the second unfold example is aiming the reduction of welding process. As you can see, by limiting the number to only 2 parts, the number of welding lines are reduced, so does the heat-affected area. The bending process, however, needs experienced skill to keep component accuracy, as bending work has to be done by visual positioning of the scribe or punched mark, since there is no gauging face on the diagonal line. To solve these issues, let us introduce a new bending method that reduces lead time while maintaining both bending and welding accuracy. The Unfold is one-piece body with slits without separating parts. In the past, it was nearly impossible to bend shapes like this, but with the new back gauge that can move front and back independently and the new stopper method, we can reach quick and easy bend quality. First, we bend the obtuse angles on the bottom surface 4 times. By using back gauge to the part's corner, accurate and steady diagonal bends can be possible. We do the same second bend onward. Creating the point gauging program for the part's corner you have just seen is very simple. When you finish bending the bottom surface, it will look like this, so the remaining bends can be done as of general box flanges. By using this bend method, we have reduced the number of welds to a minimum without increasing the bend load. Also, you have just seen obtuse bends that are difficult to achieve accuracy in Unfold, but by using angle sensors, obtuse angle bends can be precisely and easily achieved. Furthermore, high-grade fiber laser welding machine reduces finishing work after weld. Here, we would like to introduce our latest solution in blanking, bending, and welding that incorporates the processing technologies we have just introduced you. This is FOL-AJ. The fiber laser machine, high speed and energy saving on thin sheets processing. And this is LC-F1NT, the 3-axis linear drive laser machine for high-grade processing for thin to thick sheets. This is FOM2RI, an all-round laser machine for pipes, structure steel, and sheet metal. The next generation hybrid drive bending machine, HG, for high productivity even in complex shape bends and R-bends. The fiber laser welding machine, FLW, is for high-grade processing. Change the boundaries of welding processes. We have introduced our leading-edge processing technologies and solutions that will create new manufacturing for you. Amara has been striving for creating the system to reduce the lead time of high-value added products without depending on skills in whole process stages. Amara's new manufacturing proposals will drastically change today's sheet metal processing. We will continue to work with customers in solving manufacturing issues. Thank you very much for your attendance.